Hi, this is Intubation Nation with our Design Freeze presentation. The process of intubation is very invasive and navigates the delicate respiratory system in order to help a patient breathe when they're unable to on their own. We chose to improve the existing system as it is the best current technology. It was found that being able to adequately see the trachea was a common problem, leading to our first design input of increasing visibility. Additionally, it's hard to predict what size tube a patient will need, especially in an emergency, which led us to our next design input, the tube being size adaptable. It's also important to be speedy and precise, so our other design inputs became decreasing time of intubation and ensuring a safe cuff inflation pressure, which if done improperly can cause aspiration.
Through the design process, we have accumulated a total of 10 prototypes. Each of our final 4 design prompts has at least 2 associated prototypes. We selected the designs that were most feasible and valuable that were highlighted during the Mira activity. Some designs worked well, like the LED stylet, while others, like the glow-in-the-dark ETT, did not. In both the good and bad designs, we have inched closer to a final design.
In order to reduce potential risks of aspiration, the team first attempts to create a prototype that has a different cuff shape. Instead of a round, symmetric cuff from the predicate device, the new prototype offers a tapered angle with an extended edge. This allows the cuff to have an increased area of contact with the trachea, assuming the force needed to hold the pressurized seals is the same. Our prototype is estimated to reduce the pressure by about 37%, thus reduce the risk of aspiration.
The next component of the tube that was focused on was the extendable portion. These concentric cylinders function like a toy lightsaber, where they can compress and extend. The model made here was able to compress the required full 5 centimeters without compromising the shape and structure of the cylinders. Compressing this amount implies that the full range of adult sizes can be utilized.
The next component of our design is a stylet embedded with LEDs that will increase the visibility of the airway and other anatomical features to aid with intubation. The prototype showed that LEDs embedded in the stylet is an effective way to illuminate the airway and its constituent landmarks, even in less than ideal lighting conditions. This was confirmed by the RGB triplets of the pictures taken, as well as through user feedback.
The third component that the team plans to implement in the final concept design is a backflow pressure sensor. This sensor releases extra air from the cuff when it encounters trachea resistance, ensuring a safe cuff pressure and inflation. This design works like a gas station pump. Once a certain level of air is reached inside the cuff, the air supply will cut off, similar to the first click experience when filling a gas tank. The sensor guarantees that cuff inflation is consistent with every use and that the trachea sustains minimal applied force.
After developing the 4 concepts into working models, we were able to dream up our final concept design, combining the new cuff shape, the extendability, the LED stylet, and the backflow sensor resulted in a newly imagined ETT. Here you can see how each component works together to address the problems we identified and found feasible ways for our group to address. We compiled multiple components together to maximize benefit to the primary user, where ease of inserting the ETT is optimized and danger to the patient is minimized.
Concept development for the team was non-linear. Each team member developed concept models based on the following key design input metrics: increased speed of intubation, clear/improved visibility, extendability, and cuff pressure safety. 2 concept designs were developed for increased speed of intubation. The team decided to eliminate speed of intubation altogether because it was apparent that it is too broad and yielded poor results. 3 concept designs were developed that addressed the design input of visibility, the first being a glow-in-the-dark ETT, the second a mini camera, and the third concept a light-up stylet. The team decided against pursuing the glow-in-the-dark ETT and the mini camera due to poor functional testing results and price. For the design input of size adaptable, 3 extendable shape options were developed. The first concept design was the foldable option. The second concept was a section made of a soft material that crumpled under pressure. Both were eliminated because the foldable sections were problematic. Cuff pressure safety led to the development of 3 concept designs. The first is a pressure gauge pilot line attachment. The second design is a backflow pressure sensor. Giving user support for this design, the team decided to include the concept design in the final concept model.
Overall, the design of our device is driven by user needs, and the prototypes are chosen based on the feedback we receive from our primary user. Through a questionnaire, the users were allowed to see the concept design drawings and give a rating from 1 to 5 by how practical design is if they were given this when performing intubations in the field. Because the average rating for users shows the most practical designs are those that are able to detect the pressure change, it becomes one of the most important features we decided to include as part of our final design. On the other hand, we also asked our user to rate the differences between the original tube and the improved prototypes. Overall, the user feedback acknowledges that the intubation process will be much easier if there is LED lights to increase visibilities or a change cuff structures to match trachea profile.
Thank you so much for your attention today in learning about the process our team took to maximize value for our users and create our final concept design.